All right, here we are on the last section of this chapter, and this is one that you have to write your own notes for. I did not make a worksheet deal for your notes for this one. This section is 1-8, interpreting graphs of functions. All right, there's a little bit of writing to do on this section here, so get ready. So key features. We're going to look at key features of functions. These are the parts of the functions that we are most concerned about. One is intercepts. Intercepts. This is where the point where a graph intersects an axis. So we'll do an example of it here. So a y-intercept this is where the graph of the function intersects the y-axis. So at that point, x is going to equal 0. And we'll see why in just a second. For an x-intercept, this one intersects the x-axis. And at that point, y is going to equal 0. Okay, let's look at what we just wrote down here. Let's do an example, see an example of what I'm talking about. So here is a coordinate plane. And we're going to go ahead and go up 5, 1, 2, 3, 4, 5. And let's draw a line that goes through that point and goes through the x-axis here. So right here at this point, this is the x-intercept. That's where the line crosses the x-axis. Now here's the y-axis, and right here at 5, this is the y-intercept. Now let's look at both of these intercepts here, specifically this y-intercept one. So remember, this is the y-axis, this is the x-axis. Right here, this point is x is 0 and y is 5. 0, 5 is the point right there, 0, 5. Now this x-intercept, what is my y value going to be right here at this x-intercept? Let's say this is like 6, 1, 2, 3, 4, 5, 6. I'm going to say my x value is 6, my y value is 0. It doesn't go up and down at all. So that's what we're saying here. When x is 0 at the y-intercept, y is 0 at the x-intercept. Learn this because we're going to use this all the time. When the y-intercept is when x is 0, that's the one that we're going to talk about the most. But the same is true for the x-axis. The y is 0. Okay, or the x-intercept. You try. Let's draw another coordinate plane. Let's go like 5 notches, 2, 3, 4, 5 on each. Now let's go to -3, 1, 2, 3, 0. And let's go to 1, 2. Let's draw a line that goes right here. and it's a line, so it needs arrows on each side. Now we're going to name this. You try. Name the intercepts. So let's see if you can name these, the x-intercept and the y-intercept. So I'm going to say x-intercept and y-intercept. Name those guys. Go ahead and pause and do it now. Go. Okay, my x-intercept is the place where the line crosses the x-axis. So my x-intercept is a point, and that point is -3, 0. My y-intercept is right here where y equals 2. So that's going to be 0, because I didn't go left or right, I only went up. 0, 2 is my y-intercept. Now, be careful not to write -3, 2 like this. This is a point, -3, 2. That point is right here. When you're looking for an x-intercept and a y-intercept, this is the x-intercept, this is the y-intercept. Don't make it a point. It's two different points. It's something that I see on the test quite a bit, or the tests that ask this kind of question. So the x-intercept is one point right here, and the y-intercept is a different point, two totally different points. All right, let's talk about symmetry. So we talked about intercepts, now we talk about symmetry. So we're just going to look at two examples of symmetry. We're going to draw a coordinate plane, and we're going to draw kind of an upside down U shape like that. Now for this graph here, if we were to draw a line right down there in the middle of it, and if I were to fold this paper on top of itself, this would fold right on top of this one if I were to draw it, perfectly. So this side is a mirror image of this side. So this is symmetrical, and right here in the middle, where the mirror would be, that is called the line of symmetry. Now let's look at another example. This one, we're going to draw another coordinate plane. Then we're going to draw this kind of wacky graph, goes up, goes down, goes up again like that. Now there's no symmetry here. This is no line of symmetry. So this is an example of symmetry. This is not an example of symmetry. So maybe we could put like non-example, right? All right, let's keep going. We just have a little bit farther to go. Interpret extrema and end behavior. So now we're going to talk about interpret extrema and end behavior. So we're going to draw again a coordinate plane. Let's just draw a few notches on here just so you know this is a coordinate plane. Okay, now we're going to start up here in the second quadrant. We're going to draw this coming down, and then we're going to go back up, and then we're going to go down again like this. All right, and we're going to use this graph as a way to understand what is this whole thing called extrema and end behavior. Let's figure this out. Also, we're going to figure out where this graph is increasing or decreasing. Okay, let's start with increasing and decreasing. So we always read graphs from left to right. Okay, so we're going to read left to right. Always read a graph left to right. So I'm going to start here on the left. And now, if I was on a skateboard and I was going left to right and I was going down like this, left to right, down, then I am decreasing. When I go left to right, my graph is decreasing. When I go left to right, my y values are getting lower and lower. So here I am decreasing. Left to right, so I go down, and then right here I stop decreasing and I start increasing. So for this section, so here's where I stop right here at the bottom and start going back up. Here's where I stop and start going back down. So this section right here, I am increasing. So I'm thinking of my y values as I'm going left to right. So think about your y values. What are they doing? Are they going up or down? So here my y values are going down, 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 down. Here my y values are going up, 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 up. So this is increasing. And then we get here again, and now we're going down again. So we're decreasing again. Okay, so we're going to draw a little arrow going up, and that, so see this x-axis? In the sections where the graph is above the x-axis, the function is positive. So that means a positive y value, or f of x value. So if the function is above the x-axis, then the function is positive. The y values are positive. Now, if the function is below the x-axis, or that part of the function is below the x-axis, then it is negative. So I've got negative y values. Okay, we haven't talked about extrema yet, or end behavior. Look, that's the title of the thing, and we haven't even talked about it yet. All right, here we go. See this point right here? It goes, so we start way up here, we go down, boom, and we stop, we turn around, we go back up, boom, and we go like that. We go back down. This point is the highest point besides the part that has the arrow on it. So this part is like the top of a hill. And so at the top of the hill, we have a relative maximum. Relative meaning that in this area of the graph, that is the max. Over here, we have these maximums over here, but it doesn't turn and curve like that, so it's not like a mountain. Here's the relative maximum. So that means this part down here at the bottom of the valley, this is going to be my relative minimum. And all your relative maximums and minimums, that is called your extrema. Those are your extrema. The maximum and minimum, the extreme section of the graph, top and bottom, those are your extrema. Now, end behavior. And the way we think of that is as x values increase, or decrease, what is f of x doing? Or y doing? So for this example here, as f of x, as x gets greater, as we're going left to right, then my y values are decreasing. So my end behavior for this graph on the right, as x increases, y decreases. Now, as x decreases, if we're going to the left, then y increases. So if I'm looking at it going left, then y is going up. Now, as I said, we're reading graphs from left to right. And we do that all the time except for when we want to know what the end behavior is on the left side of the graph. So if we're looking for the end behavior on the left side of the graph, we got to go right to left. So as x values get lesser and lesser, then the y values are getting greater. So as x decreases, y increases. As x increases, y decreases. All right. Now, we're going to do a U-try. We're going to draw this graph. And this is the last thing we're doing for this lesson, and this is the last lesson of this chapter. Congratulations. Okay, so we're going to draw like 6, 7 up. 1, 2, 3, 4, 5, 6, 7. And we're going to draw like 10 back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be enough. And 7 this way. 1, 2, 3, 4, 5, 6, 7. Let's do 9. 8, 9. And down we can just do 5. 1, 2, 3, 4, 5. Okay, we've got a few points here. So we've got 1, 2, 3, 4, 5, 6. We've got 1, 2, 3, 4, 5, 6. We've got a point right here. We've got a point at 2, negative 2, 0. We've got a point at 0, negative 3. We've got a point at 3, 0. A point at 5, 2. And a point at 5, 6, 7, 0. And one more point at 1, 2, 3, 4, negative 4. 1, 2, 3, 4. 5. Okay, let's draw this thing. So we're going to start down here at the bottom. I'm going to go up, go through that point, go down, go through this point, keep going to the right, up, down, like this. Now we're going to interpret this graph. So we want points. Tell me the points for all of these things that, that it makes sense to do a point for. So we want the extrema. Is there symmetry? Symmetry. Right end behavior. So as x is increasing, right end behavior. Left end behavior, or as x is decreasing, what's happening to y? What is the x-intercept or multiple x-intercepts? And what is the y-intercept or multiple y-intercepts? What's going on with that? So these should be points here. This should be a point. And then these will not be points. Okay, based on what we just did, see if you can answer these questions here. And then we'll get back together when you're done and check your work. Go. Pause. Go. Okay. Welcome back. Let's fill this in here. See how you did. So extrema, so I've got an extreme point here, an extreme point here, an extreme point here. So those are my relative extrema. Now, let's look at this one here. So this is 1, 2, 3, 4, negative 4, 1, 2, 3, 4, 5, negative 4, 5. So I've got negative 4, 5, and that is a relative max. And then I have this min right here that is 0, -3, 0, -3, and that's my min. Now, I might talk about this max as well, because this is relative to this area. So let's do that one as well. So 1, 2, 3, 4, 5, 1, 2. So that is 5, 2. Notice how this max goes up to 5, this max only goes up to 2. This is the main relative max, and this is kind of a younger brother. Okay, symmetry. I can't really find, like this could almost flip over like that and have a line of symmetry right here, but not quite, because this is lower than this. So no, this doesn't have any symmetry. Right end behavior. So that's as x increases, y is decreasing. So I'm going to say decreasing. As x, so on the left end, as x decreases, y is also decreasing. So both of these are decreasing. So the arrow is pointing down on the right, the arrow is pointing down on the left, so they are both decreasing. X-intercepts, I got a bunch of x-intercepts. So I've got one at 1, 2, 3, 4, 5, 6, 6, 0. I've got one at -2, oh, not +6, -6, -2, 0. I've got another x-intercept here at 3, 0. And another one at 4, 5, 6, 7, 0. So those are my x-intercepts. My y-intercept, I only have one place where the graph is crossing the y-axis. And if this is a function, that will always be the case. Any function will only go through the y-axis one time. And this is at -3, so 0, -3 is my y-intercept. And that is the end of 1-8. Do a good job on the homework. I know this is kind of a lot of stuff and a lot of words that are different than we're used to using. So, so really dig into this so that as we move forward, you'll be prepared and understand what it is coming out of my mouth as far as words go. All right? Good luck on the homework.